All right, everybody, we are looking at the precise definition of limits. You might also see this called well, there we go, the epsilon delta. Where epsilon, we had the Greek letter epsilon and then the Greek letter delta. So you might also see it called the epsilon delta definition. So looking at it, we've got our limit of a function. Okay, and it starts off the same way. We're defining our limit here. Okay. And so we say that the limit of f of x as x approaches a is L if for any number epsilon greater than 0, there is a corresponding number delta that's also greater than 0, such that these two inequalities hold. Okay, so if we subtract the limit from our function, that's going to be less than our epsilon, and if we subtract a from x, that's going to be between 0 and delta. Okay, so a lot of ways you'll see this is if we know L, we know what our limit's equal to, and epsilon's greater than 0 is given to us, then we can draw horizontal lines, L minus epsilon and L plus epsilon. So for example, if we've got our function here, okay, so we are looking at a point A. We know we've got some value of L. Okay. And so then we know we've got some value epsilon, so we get two lines, one on either side. We get L plus epsilon, L minus epsilon. And so we can track them over and we can find what points they intersect with our graph and drop down to get our A minus delta and our A plus delta. Okay, and then we can subtract A minus delta and A plus delta and A to give us our delta value. Okay. Something to note is that as epsilon becomes smaller, our delta will also become smaller. Okay, so we might be given something like, they might give you a graph, or they might give you the numbers and have you draw the graph. In this case, I'm going to give you the graph. So let's say we've got a function like this. With these values. Okay, so let's say we're given this graph that looks like this with these values. And so we're going to use this graph to find a delta value. Okay. So if we look, we've got, okay, 0. We've got an absolute value of x minus 2.25 is in between 0 and delta. And so this 2.25 is our A value. Okay, let me use a different color. That's our A value. Okay, and we can see it down here. Okay, and then we know that f of x minus 2.159 is, get another color. That's our L. Okay, so that's our limit. And then we've got that that's less than or equal to one, so that's our delta, our epsilon. Okay, so we get L plus epsilon is our 3.159, and our L minus epsilon is our 1.159. Okay, so what that means is that this 1.404 is my A minus delta. Okay, and this 2.991 is my A plus delta, because they correspond to our L plus E or epsilon and L minus epsilon values. Okay, so to actually find delta, I'll subtract. So I'll do 2.25 minus 1.404. This should be a 9. Okay, and so I get 0.841. And then we do the same with the others. So we get 2.991 minus 2.250. And we get 0.741. Okay. Now, sometimes you'll do this and you'll get the same values. Great. It's just that's your delta value. In this case, we had 2 different ones. So we picked the smaller. So our delta is equal to 0.741. Okay. So it's one way you'll see questions. And sometimes they might give you the graph, sometimes they might give you the information and have you graph it. Either way is done about the same way. Okay, so then the other big thing with these questions is if we want to prove using this definition that the limit as x plus a of f of x is equal to L. Okay, so this should be called our epsilon delta proofs. Okay, and all that means is we're going to find a delta, we're going to calculate it, and then we're going to write a proof or mathematically show that that is true. Okay, so first step in proving that our limit is equal to L is that we'll need to find delta. Okay, and so we let epsilon be any arbitrary positive number, so that just means it's any number greater than 0. Okay, and then we use this inequality to find a condition of the form x minus a is less than delta, where delta depends only on the value of epsilon. Okay. So they'll give you, so the way these will work is they'll give you a function. You let epsilon just be some arbitrary number. You will set this up and then solve down, and you'll end up using this fact to find delta written in terms of epsilon. Okay. And so then once you have that, then we can do a little backtracking and we can write a proof. So you'll say something like, for any epsilon greater than 0, assume whatever that piece it is you found in the last problem. And you'll then go on and use the relationship between epsilon and delta that you found up in step 1 to prove that the absolute value of f of x minus L is less than epsilon. Okay. So, all right, we'll do some examples. Okay. Or well, one example, and then we'll do some more examples in class. So we're going to use the epsilon delta definition of a limit to prove that the limit as x approaches 3 of that function equals 4. Okay, so our first step will be to find delta. Okay, so what do we want? We want the absolute value of x squared plus 2x minus 15 over 2x minus 6 minus 4 less than epsilon. Okay, so we've got, looking at our limit, we know we've got a here, we've got L is 4, and we've got our function. Okay, so we use these to set up our inequality here. Or sorry, wrong step. Use this to set up our inequality like this. And we're going to solve down until we get something of this form. So we're going to take this and we're going to simplify down until we get something of the form x minus 3 is less than something times epsilon. Okay. All right. So knowing that x minus 3 is our goal on the inside of our absolute value, we'll first factor. Excuse me. So we'll first factor and see what we can do. So we see that the numerator will factor into x plus 5 times x minus 3, and the denominator will factor into 2 times x minus 3 minus 4, still less than epsilon. So then we cancel our minus 3's and we get x plus 5. We get 1/2 x plus 5 minus 1/2 times 8 . Let's do this in 2 different steps. Okay, so here, let's leave this as minus 4. Okay, so all we did was simplify the x minus 3. So then, I notice, hey, I've got a 1/2 here, and if I could probably factor a 1/2 out of this, or I can rewrite 4 into 1/2 times 8. Okay. Since I can rewrite it that way, I can factor out my 1/2. So I get 1/2 times x plus 5 minus 8, which simplifies down to be 1/2 x minus 3 is less than epsilon. So then I can multiply over to get x minus 3 is less than 2 times epsilon. And that's our form that we wanted up here. Okay, remember we wanted absolute value of x minus 3 is less than something times epsilon. Now it is possible for that something to just be 1. Okay, and so you just would get x minus whatever is less than epsilon, which is fine. So we get it down to this. And so what this tells us that delta is equal to 2 epsilon. Okay, so that was our solving for delta part. We're solving for delta in terms of epsilon. Now, we'll do the second half of this, which is to prove it. Okay, so all of your proofs are going to be formatted about the same way. You'll have let epsilon be greater than 0 and delta equal to something. Then for something, then for absolute value of x minus some blank is less than delta, we have, and then whatever your function is. Okay, so you'll start off this way, and then we'll fill in. So we know that delta is equal to 2 epsilon, and it's x minus 3 is less than delta. We get that because we know that x minus 3 is less than 2 epsilon, which is equal to delta. Okay, and so then we'll take what we started with. So we had x squared plus 2x minus 15 is over 2x minus 6 minus 4. Okay, and we want to show that this is less than epsilon. Okay. So this is our f of x, absolute value f of x minus L. We want to show that this is less than epsilon. Okay, so what we'll do is we'll do similar to how we started first one. Something to keep in mind is that we know that x minus 3 is less than delta. So if we can get down to x minus 3, we can use that. Okay, so anytime you start these, start by knowing you're trying to get to whatever inequality you defined in the beginning. Okay, so we'll go ahead and factor x plus 5, x minus 3 over 2x minus 3 minus 4 is equal to 1/2 x plus 5 minus 1/2 times 8. So it's 1/2 x minus 3. Now, we know that x minus 3 is less than epsilon. So 1/2 x minus 3 is going to be less than 1/2 delta. Okay, because we know x minus 3 is, I think I said epsilon earlier, but I meant delta. And we know that delta is equal to two times epsilon. That was what we defined. And that just simplifies down to epsilon. Okay, so that means we'll use therefore. Therefore, absolute value of x squared plus 2x minus 15 over 2x minus 6 minus 4 is less than epsilon. Okay, which is what we wanted. Okay, so anytime you're doing this, you'll follow this basic format. Okay. And we'll do some more examples in class. I think the best way to kind of learn these is just by practicing.